Hi, welcome back to the Calculus 1 lecture series. And this is the second part of our lecture number 13, the derivative of logarithm function. In our first video, we introduced the formula for the log functions. How do you take the derivative, like with the natural log or with any common base, right? And now for the second part of the video, we're going to show how to use log function properties and try to help us to simplify, to simplify the derivative. Then we're also going to take a look, how do we define this e, the exponential 2.7127 something, right? So how do we define that and how do we find the limit by using that properties here? Okay, so now let's go to our worksheets here. So we stopped the last time. If you take a look, we stopped the last time and just practicing the general formula for the log functions here. Okay, so now let's see here. We said, how do I use the log differentiation to take the derivative of a function? And this one's here, so you don't have a log function and you just have some regular f of x function. So how do I do that? Okay, so now we have 4 steps here. Okay, so we have 4 steps here. So like, let's see the number 1 here. We say, let's take natural log both sides of y equal to f of x. So basically what you do here, so you say, hey, I'm just taking the both sides. So this is natural log y equal to natural log f of x. All right. And then the second step here, we know the log function has a set of very good properties. So second step, we say, because we want to simplify our derivative, right? So we say simplify this number natural log f of x, right? Using the property of the logarithm. Okay, so maybe let me color coding that. So I want to simplify the natural log f of x here. We just did from the first step here. And then let's take a look at step number 3 here. I want to differentiate both sides implicitly. Right, remember we talk about the implicit differentiations, right? Then after we do that, then the step number 4 here, I'm going to solve for y prime. Okay, so so what is, so how do I solve for y primes here? Because your left hand side is natural log y, right? So your y primes here will be what? Will be the y times, you take the derivative of your natural log f of x here. Okay, now let's take a look from some examples here. Okay, so first one is y equal to the 6x. Of course, you can say, hey, I just used the formula you told me from the previous lecture. That's fine, okay? So, but how about if you say, I don't remember how to do that, right? So what you can do, I said, okay, let's do the step number 1. We say, let's take the derivative, take the natural log of both sides. So I have natural log y is equal to the natural log 6x, correct? Okay, and then they said the second step here to try to simplify it. So I know if a natural log is here, I have exponents. What happens here? You can move this exponent to the front, right? So I can have x natural log 6. right? So that's one of the log properties, the exponents property. We have log plus log is log multiply, and log minus log is log divide. And then if you have exponents, you definitely can move the exponents to the front. Okay, now let's take the derivative implicitly. We know y is a function of x, right? So now when I take the natural log of y, so from the log derivative, I know what is y. Natural log of y here is 1 over y. And don't forget, remember we talked about the implicit differentiation. So basically, this is my first layer. This is my second layers, right? So what I need to do is here. So it's 1 over y, and then you need to do what? Times y prime. Then the same things here. So this is x natural log x. You take derivative of x. So what do you have left is natural log x. Now to solve for y prime, because you want to solve for y prime. So y prime is just what? Y times natural log 6. Right? You just multiply y both sides. Now what is y here? Y is 6x to the natural log 6 here. Right? So that is match what the formula we talk about in our previous lectures, right? Okay, now let's take a look at this one here. Okay, so for this one, if you want to find the derivative, so of course, what you can do, you can use like, you can use the power rule. So this is my first layer, and then this is my second layers, right? So you can say, you can do this, no problem for that. So this is y prime, so it will be 4, whatever's inside here, right? So this is a 10x cubed square roots of x plus 1. Then this is a 3. Then you need to times the derivative of this green things, right? Then it looks very complicated. Then you need to use quotient rules, right? So it's kind of complicated. Let's see how is the log help us. It's really cool, right? Let's see how is the log can help us. Okay, so let's see here. Let's take the log both sides, right? Just follow the step. So I say take the log both sides. So this is a log. So this is 10x cubed, and this is x plus 1 to the 4th power, right? Okay, so now the first things here, I use the exponents, log exponents here. So this 4, I can move forward. So this is 4 natural log 10x cubed. Then here, the x plus 1 square root, so it's x plus 1 to the 1/2, right? And now you say, hey, I know the log, when you divide, is a log 10x cubed minus log x plus 1 to the 1/2, right? Okay, so now I can use the log property one more time. So this is, hey, the log multiply will be log 10, then plus log x cubed, right? Then in here, I can move this exponent to the front by the log functions. So this is 1/2 log x plus 1. Okay, now you see, oh, here I have one more thing that I can simplify here. This is log 10. And you see, hey, here I have another exponents. So what I can do here, I can say plus 3 natural log x, then minus 1/2 natural log x plus 1. Right, so I simplify it a lot. Okay, now I take the derivative of both sides here. I take the derivative of both sides. Now I need to take the derivative of this natural log of y here, right? Okay, so what is my derivative? Will just be 1 over y and times what? Y primes, right? Okay, let's take a look at the derivative of this ones here. Okay, so the derivative of this one, okay, so let's take a look. Natural log 10, this is a constant. So what is this going to be? Is 0. Okay, so what is this derivative going to be? So will be 1 over x times 3. then this is 1 over half. So what is here? This is just x plus 1, right? Then your chain rules is times 1 is here. All right, so now, see here, now your derivative is super easy, right? So this will be the 4. So if you want, you can say this is the, you can simplify a little bit. So you can say this is the 12x minus x plus 1, 4 times 2, so this is 2, right? All right, so after that, then the last step, you will say y prime is just equal to the 12 of x minus 2 of x plus 1 times what? Times y. Now what is the y? So this is 12x minus 2 of the x plus 1. What is the y here? This is 10x cubed. Square roots of x plus 1 to the 4th. You see here? So that's why you use the log properties, which will be able to help you to simplify a lot. Okay, let's take a look at this one again. See how do we? So we say the natural log f of x, right? So it's equal to, oh, this one we don't even need to take the natural log because this already have a natural log here, right? So here, let's just try to use the log property. So this is the natural log. The whole thing's here, I can say this is x squared plus 1, 2x cubed to the what? To the 1/2, correct? Okay, now for this exponents here, this is the exponents here, right? So I can move these exponents to the front. So this will be 1/2. Then this is a natural log to divide. You can be what? Minus, right? Correct? Okay, so now you can take the derivative here. So you simplify. So f prime x here will just be 1/2. And then here, what is here? You put the whole thing in the denominator. So it's x squared plus 1. Then you take the derivative of x squared. What you have is 2x. Then minus here. So you can put the whole thing. So it's 2x cubed. Now, what is the chain rules here? Is 6x to the what? Squares, right? Okay, so now let's simplify this a little bit. Okay, so like this one, the x squared can cancel to get x left. 2 can cancel, got a 3 left. All right, so now if the final answer will just be, you can FOIL that out. So this will be x squared plus 1 is still 1/2 here is minus 2/3 to what? You have 1 over x here. Okay, so that's why we said how do we use the properties of the log function and really will be able to simplify our derivative, especially like this one's those type of the functions, right? If you want to use the quotient rules, it's going to become pretty tedious. It's not hard, just very tedious and have a lot of chances to make some algebra mistakes here. All right. Okay, so the last things for this section, we're going to take a look at this number e's, right? We have using that. We said this is an irrational number. It's 2.7128, da, 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 da. So how do we define this e's here, right? So how do we use this definition to help us to solve some limit problems here? Okay, so this is the definition of the E. So this is how do we define with a limit, okay? If the T approach to infinities here, then this is 1 plus 1 over T, all right? And to the T's exponents, then the whole thing's here going to approach to E's here. Okay, so be careful. Look at the two things here. So these terms here, right? And these terms here, right? So let me see if I have some exponents here. If you take a look, when the t approach to infinity, this purple term, what is this whole purple term approach to? Approach to 0, right? Then this green term approach to what? Approach to infinity. So basically this 1 plus, approach to 0 to the infinity power is here. Okay, so now let's try to use this definition to help us to solve some other limit problems here. Okay, so be careful here. Okay, so now let's take a look at this one here. So this one, this is 1 plus h, 1 over h. Obviously, this is a different format here. But in here, right? So in here, they said h is approach to 0. So now, if I set the h is equal to 1 over t, let's see if we can change this one to some form we recognize. If h equal to 1 over t, so what is the 1 over h going to equal to? 1 over h going to equal to t, right? Okay, so now when the h approach to 0, so when h approach to 0 here, that means this number going to approach to what? This number going to approach to zeros, right? So this will be very similar. It's just like we say the limit, the t approach to infinity, 1 over t here, right? Because 1 over t is the approach to zeros here. Do you see here? Okay, so that's why for these terms here, right? So this term, we can rewrite this is equal to limit. When h approach to 0, really will become t approach to what? Infinity. Then this is 1 plus 1 over t. Then what is 1 over h here? 1 over h is t here, right? So because we know 1 over h is equal to t. So now let's see here, this one, when h approach to 0, right? So this approach to infinity. So match. And the same ways for this one, see here, 1 over t. When h approach to 0, right? So t approach to infinity. So now what is the answer here? So we know that limit here, this is here. Okay. So now let's take a look. The next one here. So this is limit 1 plus 1 over x to the 3x. You say, oh, this one looks pretty similar because it's x approach to infinity. So x is kind of like it's my t's, right? So let me rewrite to see I can match this definition. So this is x approach to infinity. So 1 plus 1 over x. Based on my definition, I only have t's here, so I only have x here. Then the whole things here, I have 3 here, right? Okay, so now you inside here, take a look. X approach to infinity, this one approach to 0, and x approach to infinity, this green one approach to what? Approach to infinity. So this form inside this bracket exactly match my definition of E. So what is here? So this will be E's, right? But then outside I still have a cube. So what is here? E cube. Cool. Okay. Now here, this one's here. So this is the limit x approach to 1. All right, 1. So what is the 1? See here, right? It doesn't look like here. So let's think about, let's say x minus 1. Okay, so you say x minus 1. Let's say x minus 1 equal to what here? I said, hey, let's see, x minus 1 equal to t, right? So if x minus 1 equal to t here, okay, and so when the x approach to 1, so when the limit x approach to 1, so what is my t approach to? So limit when the x approach to 1, so here the top is x minus 1, right? So when limit x approach to 1, so this will be infinity. So this is equal to limit what t approach to what number? Infinities here. Correct? Take a look here, right? So this, take a look here. So this one here is x minus 1, right? So x minus 1, when x approach to 1, this approach to 0. But this is x minus 1 equal to t, so 1 over x minus 1 is what? I'm sorry, so the 1 over x minus 1 is 1 over t, right? So it's 1 over t, right? So it's 1 over t. And so this one's here, it will be what? This will be approach to what? Approach to infinities here. Correct? All right. So the 1 over x is here will be equivalent to t approach to the what? T approach to the infinity. I'm sorry, here should be the 1 over x, so it's 1 over t. Okay, so 1 over t, and so this is equivalent to t approach to the what here? So this one will be equivalent to t approach to the infinities. Okay, so here I guess here let's try to redo this so it kind of will not cause the confusions here. And I think I was like make this is not very clear. Okay, so let's try to do this one here, right? So this is 1 over x minus 1 here. So let's set the t. Okay, I should do this, right? Let's set the exponents here. So let's set the t is equal to 1 over x minus 1. Okay. Okay, so 1 over x minus 1. So limit x approach to 1 of 1 over x minus 1 is equal to limit t approach to the infinity to the t's here. Okay, so now t is equal to 1 over x minus 1. Okay, so since t is equal to 1 over x minus 1, you flip it. 1 over t is equal to x minus 1. Right now you plus 1 on both sides. So what you have here, you have 1 plus 1 over t equal to what? Equal to x. Okay, so now these things here, I can rewrite it. So this is a limit. X here, I just did. X is 1 plus 1 over t. And so the 1 over x minus 1, the exponents here, this is the t. So the x minus 1, like we say here, x plus x approach to 1 is equal to t approach to infinity. So this is approach to infinity. Then take a look. This is exactly what our definition of the is here, right? So here you go, right? So now what is the answer for here? So this one is what? So the answers here, this is here. All right, so the x to the 1 over x minus 1. So this approach to is here. And we're going to use this type of the limits in the later sections. So when we try to find, when we try to take the derivative, if the exponents go to infinity, or, we're going to use those limits here. So now how to do that. All right, that's it. Let's use this sections, this video. We talk about how to simplify it by using the log function properties. And also we revisit the definition of the E, and then use this definition to help us to find some limit. Probably sometimes it's different than what we wrote as the definition, but then after you can do some algebra manipulation and change into the form to the definition of the number E, and then we'll be able to get the limits. Okay, that's it. And that's what we finished, the derivative of the logarithms here. Okay, it's a nice talk to you, and looking forward to work with you on the next topics here. Okay, bye.